Hello, welcome to the AEO-Light video tutorial series. AEO-Light is software that extracts digital audio from scans of motion picture films. It is based at the University of South Carolina and made possible by funding from the National Endowment for the Humanities. In this video, I will provide a basic introduction to the software, taking you through understanding the interface, opening a project, setting the audio extraction parameters, testing those parameters, and then extracting a broadcast wave digital audio file. So let's get started. To open up your audio source file, we're going to start by going to New Project. By design, AEO-Light is optimized to work with frame-based film scans, that is, film scans that are DPX files or TIFF files or OpenEXR files. These are folders filled with thousands and thousands of individual pictures. Most scanners can produce some kind of DPX or some type of video. We're going to start though with a video sample. We're going to go to 16 millimeter, and if you have a video source file, for example, on a Mac, you might need to go to options and change the desired input to video file, and that'll allow you to select. If you're working with video, you want to buffer the incoming video. And now I get a second window, and this second window is the images from the film scanner. So it's my video file. And here we have an Air Force film called Roger Windsock, Wings for Roger Windsock. 16 millimeter films have the optical soundtracks on the right. When you're using AEO-Light, you're going to get used to noticing the difference between variable area sound and variable density sound. This is an example of a variable density sound in which the audio information here on the right is encoded through changes in the density scales on the grays. We can see that way. So let's look at the interface. We have a soundtrack setting. This is the main frame of the software, and it's the place where we're going to put all of our most important settings. Depending on the film scan and the optical soundtrack that we're looking at, we might come in to do a little extra processing here in the image processing section, and that includes desaturating the track in case that is an issue. If we're working with a negative soundtrack, it allows us to click that, and then we can make some important things happen to improve the quality of negative audio. And also, depending on the nature of your scanner, you may notice that you have light irregularities, that light in one part of the frame may or may not be as strong in another part of the frame. And if that happens over the area of the soundtrack, that can actually slightly distort the audio. So if you feel like that might be an issue, you can actually calibrate the entire source by clicking that button. It'll take a few seconds or minutes depending on the nature of your computer and the size of your input file. We can look at extract audio, and in this frame we can set an in and out point from wherever we have as our input sources. We can change our sampling rate from 48 to 96. We can go from 16 to 24 bit. We can set the time code advance, and what this is really the frame offset, the distance between the start of the audio and the start of the image on the motion picture film. For 16 millimeter film, it's actually 26 frames. I'm going to go ahead and set that now before I forget. And if we've been working on a lot of projects and we're saving our render time to later in the day when we go to lunch, we can actually build a queue and add things to the queue, and then tell the program to extract them while we're away from our desk. So let's go back to soundtrack settings. Let's look carefully at what we have here. We have a bounding box, that's what these sliders are, for our soundtrack. We have a bounding box for our picture strip, which is this yellow thing in here in the middle. We have a frame pitch start and a frame pitch end. This defines where the beginning of the frame is on the scan and where the end of the frame is on the scan. I'm going to put those there for a second. And search size. In general, we encourage you not to touch the search size, as it kind of changes the math a little bit, and it can either slow the program down immensely or make it unable to actually find and calculate the correct overlap from one frame to another. So soundtrack settings. This is the most important one. This is a mono track. There's only one channel of audio here, but if this was stereo, we would change this to stereo. If it was a push-pull track, which is a special type of track, and we would move it to push-pull now. But we know this is a mono track, and we'll leave it there. I'm going to go ahead and slide my left bounding box over to the left side of the optical soundtrack, and then my right bounding box line over to the right side. And one of the things when we set this left bounding box over here and the right bounding box over here, we do not want to push it all the way over to the right because we might introduce noise, and we do not want to align it like here just off the left side because we'll introduce extra noise. We actually want to kind of set it nicely in the middle, and we can kind of click forward here and see some things happening. The picture strip is by default turned off. I can turn this picture strip on. In short, what the picture strip does is it pretends that the information inside of it is like audio, and it will extract the pixel information from inside this area and add that to the calculations that the algorithm in the software are performing. It can improve the audio, or it can also distort the audio slightly. That's why we leave it off. You should leave it off by default unless you find that you need it. The frame pitch start with a 16mm film is usually pretty easy. We have this frame line is this black line in here. We want to go ahead and line that up over top of that. And then we have a frame line down here at the bottom, and we want to go ahead and line this over top of that. And what you can see, if you look down here, is the way that the movement of the frame pitch start and stop changes the relationship of these little audio wave snippets. This green snippet here is actually the audio from this section of the film scan. This red snippet here is the audio from this section. Whatever is inside of here matches up with here. So we have this is our search area here. This is our search area here. So all of this red is this audio from this section, including the overlap. So let's go ahead and move this. And what we can see, for example, is this red audio, which represents the audio from this previous frame. I've moved it now in such a way that it aligns as a correct overlap. And we can see that here where we've got green and we've got red, they don't match. But that's down here outside of the search area, and so it's not important. We've got green and red and they don't match, but that's up here and it doesn't matter because the software is really only looking at this area here, and what we have is a nice yellow. And that lets us know that the audio is lining up. So let me click through this a bit and see how we're overlapping. And actually, I may go ahead and add the picture strip here. What that picture strip does is then looks in the search area and adds this information into the matrix to see how it can improve the audio. I've got some samples. Let me go ahead and set in. The next thing I want to do is just, my parameters are set. I want to go ahead and hit new sample. And what this will do is it will render out 5 seconds of audio based on the settings that I have currently.
I can't fly. What'll I do? They don't work.
There's a nice little bit of audio there. I can hear a bit of noise that I might be able to remove with a bit more fiddling with some controls. But let me go ahead and save that in slot 1. So now, if I move anything at this stage, if I want to go back, I can hit load settings and see how those slider bars went back. So these new samples, play sample, load settings are very kind of useful as you kind of tinker with your audio before extracting. I think the issue here that I may actually want to do is to calibrate this track. I can actually see that there's a kind of a bit of a parabola here that is probably due to the lighting on my lamp house. This is going to take a few seconds, and we'll do a little kind of cooking show fast forward here to get to the end of the calibrate, but this is how the process works. All right, that wasn't too bad. Let me go ahead and advance the frame and bring the frame back just to kind of refresh that screen. You can see that my green line is actually now fairly flat. This blue line that you now see is actually an indication of where my scan was. So I can actually toggle this off and on, and you can see how that without the calibration, my audio signal is bowing a little bit, and I really want it to be more of a straight line. Let me go ahead and kind of buff through here a bit. See, everything's looking a little bit better. This is really fine. I can't see much there. If I want to see it in detail, I can go to waveform and zoom. Again, I'm looking at the green area here. Don't get distracted by this over here on the left. So not a lot of noise going on, but that looks pretty good. I'm going to take that off. Let's go ahead and set in here and have a new sample.
It's a fire! Bear!
So the crackles of the fire are actual real crackles, and the voice sounds pretty good. I should probably find a better clip. So let's go ahead and just see what this audio sounds like. I'm going to just randomly go back to about 1,000 frames in and extract about 1,000 frames. I've got my sound time code advanced set for 26 frames, which is the standard for 16 millimeter. If I wanted to add it to a queue, I could do that now, but let's go ahead and hit extract. I'm going to name this output file Roger 1. Let me actually correct that. I'm going to name this output file Roger 1, and I'm going to select where I want to put that. I'm going to put it in my folder on the desktop. Audio output. Save. If I wanted to create a video output, I would click this button, and it will, by default, use the same file name, and then I can navigate to video output there if I want. This will create a reference video that is a compressed version of your original video file with the audio synchronized to it, and again it will use the synchro setting that you've put here in the sound time code advance. So if this is not set, you'll get a video with audio that doesn't match up correctly. And I'm going to go ahead and create both the broadcast wave digital audio and the output video for this extraction. Depending on your computer's GPU processing power and the size of the input files, AEO-Light rendering can go from either 5 frames per second, all the way up to 40 frames per second. DPX files and TIFF files extract more quickly than video files do. So now you can see the sound extraction is complete. That came in at 4.3, 4.4 frames per second. It was a large Apple ProRes video file. So let's go ahead and click OK. If I want to see my video output, I can look here and...
The XB303 at 20,000 feet. You'd know all about dihedral angles and cold fronts and wind drifts. And you'd know Mach numbers better than the multiplication tables. And the reason you'd know all this stuff, oh, there's the reason right now. Roger Windsock, the airplane kid, known on Shady Lane as the boy aeronaut, who's always looking up instead of where he's going. His father says he's air-minded, but neighbors call him plane crazy.
That was Roger Windsock, right on the beat. Hey!
So that sounds pretty good. If I wanted to hear the audio file, of course, I would go to audio output and
then the XB303 at 20,000 feet. You'd know all about dihedral angles and cold fronts and...
Given the source material, a 16mm government film animation, that sounds pretty good, and in fact that's probably about as good of an extraction as we'll get from this source file. This concludes our basic introduction to AEO-Light 2.